have chosen cope elimination as my reaction. The cope reaction of N-oxides, which can easily be prepared in situ from tertiary amines with an antioxidant such as pericid, leads to alkenes via a thermally syn elimination in aprotic solvents. The starting amine must be tertiary for this process. Using a secondary or primary amine will lead down other reaction pathways. The sterically demanding amine oxide function reacts preferentially with the more easily accessible hydrogens and often gives good selectivity favoring the less substituted alkene. Thus, for simple alkenes, this reaction follows the Hofmann rule. Cope elimination is regioselective. Unlike intermolecular E2 reactions, it does not follow Zaitev's rule. The major product is almost always the least stable alkene. This trend is most likely due to the fact that the less highly substituted beta carbon bears more hydrogen atoms than the more highly substituted one. At a given moment in the sample of substrate, there are more molecules in which a hydrogen atom on the less highly substituted beta carbon is syn paraplanar to the leaving group than there are in which a hydrogen atom on the more highly substituted beta carbon is. The cope elimination is a syn paraplanar elimination in which 6 electrons move in a 5-membered ring according to a concerted, thermally induced mechanism to yield an alkene and a hydroxylamine. As you can see in this slide, the Hofmann rule is being followed, with the alkene being on the less substituted carbon. Increasing number of species in a solution means greater entropy, which means that the negative T delta S term in the Gibbs equation increases in value as temperature is increased. Increasing temperature speeds up the reaction, as well as making delta G be negative. This also lets us infer that K is less than 1. Because cope elimination is an elimination reaction, that means there will be fewer products than there are reactants. This is how I predicted the energy diagram. In 2016, there was a study done on reverse cope elimination of hydroxylamines and alkenes or alkynes, theoretical investigation of tether, length, and substituent effects. Because of this, it says that in intermolecular reverse cope eliminations, alkynes are more reactive than alkenes.